So I will here today talk about or an analysis of how circular garments are, or how well they are prepared for sustainability and for a longer life. I will present to you some tools for how to do that. This very often when we speak about circularity and keeping things alive, giving garments a longer life, we tend to focus on one thing. So, for example, one mistake that I often bump into is that a company or anybody thinks that, yeah, because I have a very good material and this material is very good for longevity, it fits well in different recycling loops, it fits well in existing infrastructure for recycling, then my whole business is circular because I have such a very circular material. And then because you have this super circular material, or then you think that, well, this is then I have a circular business model. But circularity is larger than that. It also has implications on the business model and on your design strategies. And it's and you also hear many expressions around this. You have circular business models for longevity, circular business models, etc. And many of them are very similar. They contain the same things. And that is important to remember, that it is a part of a bigger thing, and also that there's no trade-off between this. You can't, as I try to say, change or adjust for a shitty business model with great materials. So the purpose of this exercise or this lecture is to give you tools to make an assessment of your textile product, to see how good is it, how well adopted is it for circular flows, and how sustainable it is it. And normally when we do this type of things, we also have to understand that this is not something that you do once, but something that comes back, and you need to have a continuous work around this. You are probably all familiar with the plan, do, study, act cycle. Normally a normal engineering cycle. Same thing here. Especially also since development is since the development around this area is quite rapid. For example, I read in I don't know, in the newspaper this morning that the new world conflict is about who will be the greenest continent. So is China going to be the greenest continent, or is Europe going to be the greenest continent, or is it the USA that's going to lead the green revolution? And they have actually found a way to fight around that too. So, but there will be a lot of development in this field because of that. So then it's relevant to have a continuous work around this. The tools that we will look at here is material circularity indicators from Ellen MacArthur Foundation and the Higg Index. These tools are very relevant in this context because they are generally accepted. The Ellen MacArthur Foundation was, I would say, the ones who brought circularity to more people's minds. And also made it very accessible. It sort of I would say that they were the ones who took this from the scientists and made it available for everybody else. And we also have the Higg Index. That is relevant because I think 40 or 50% of the world volumes of textiles can be associated to companies who are members of the Sustainable Apparel Coalition and who use the Higg Index. And in the next coming years, it will likely be more used too, because of coming product responsibility, due diligence legislation, and chemistry legislation, and so on. And the Higg Index can be a help in the work around that. I propose that you read up a little bit on different types of textile and materials, and that can be relevant. And I think that this book, the Sustainable Fiber Toolkit from TEKO Foundation in Sweden, is a very useful book for understanding the sustainability properties of different materials. It includes a very comprehensive list over most of the textile fibers that we use. Maybe if for Husqvarna, maybe that this the sort of what is it called, the fibers that you have as a chainsaw protection. Maybe that I don't know what that material is. Is it glass
Kevlar?
fiber or Kevlar? Maybe Kevlar. Kevlar is not in there.
Okay.
You have also this, the fiber Bibles from Mr. Future Fashion, which also I think is good. They can also give you a very comprehensive view of different textile fibers, and how. And you can also get some LCA data from these reports, and it can be very useful. It's not very difficult to read. This one is it's fuller or richer than the Sustainable Fiber Toolkit, but I think it's not very complex, and you can also get some detailed understanding about the climate impact of your textile fibers. And then you have the Preferred Fibers and Materials Market Report from Textile Exchange. These are the latter two, the one from Mr. Future Fashion and from Textile Exchange. Those are for free, but the Sustainable Fiber Toolkit has some cost to it. I think it's 200 or 300 crowns or something like that. But the other ones, but if you're a member of TEKO, they are free, I think. But the other two, they come free of charge, and you will essentially get the same information from all these three. So use this as a good reference for materials. And also, I think a heads up here is that it's always the same, that you will not love any of these tools, but you should understand how they can be used to evaluate your product. I think the apparent downsides. Oh, there's a chat here. Okay, tack. Polyethylene. Okay. Oh. Yeah, apparent downsides of these different tools is that there is no very clear longevity perspective in Higg product module. So the sort of it's very focused on cradle to gate, and there's very few questions about the use of the material, and very few questions about how they can be recycled. And the questions that is around how they can be recycled are quite diluted from what it was supposed to be from the beginning. It used to be very detailed around how they can be recycled and how they can, if they fit in current or coming waste streams, if the garments can be easily disassembled, and and then the different parts can be put in different recycling streams, but that has disappeared. So that is a little bit sad. And also, as I said, no clear end of use perspective, but there are actually now questions about overproduction, and that is good. The longevity perspective is difficult to measure in the material circularity indicators from Ellen MacArthur, and the material circularity index is also not very clear on how waste from production is handled. Some textiles have very high waste in production. Normally you have around I think it's up something around 90% cutting efficiency. When I speak to the suppliers of cutting software anyway, they claim that they can have such high, but perhaps it's mostly around 80% cutting efficiency. But some products, of course, have much lower, and cutting results in a lot of waste, and this waste, of course, needs to be taken care of. But in this index, in both HIG index and material circularity index, it's not clear how this cut waste is treated. And I think you should use these tools according to rather approximately right than definitely wrong. So maybe you can get to 80% correct with these tools. And for now, I would think that is enough.
Will you explain Higgs index and what it is more?
Yes, I will come back to that in a few slides. So what are the challenges of assessing a garment's sustainability? Well, number one, there is a lack of standardized methods. We are participating in a standardization work now, but in general, we're lacking methods to assess a garment sustainability. Even if the HIG index is probably the most standardized method, it is still it's only for larger corporations, and it's difficult for small companies to handle it. And also, it is not agreed. The HIG index is not a standard such as an ISO standard would be. So yeah. And the ones that you have, they don't mimic reality enough. They are not that exact. Then, so design and product development decisions regarding a garment's sustainability is very much up to the organization, the designer, or the product developer's experience. We have accessories and things like that are a little bit it's not as updated as it could be. There has been a lot of work around sustainability on materials and making materials as sustainable as possible. But when it comes to accessories, it's still lagging behind a little bit. For example, for assembly and disassembly of zippers, it could be made much more easy for the consumer or for the brand to change the zipper once it's broken. So in general, everything becomes an assessment of a garment's sustainability. You will not get data for many years on how sustainable is a garment. It will be an assessment. So the material circularity indicator, the MCI. So it is a tool or a tool for assessment to help companies with buying materials, setting up processes, recycling processes, and things like that. And it can also help to identify circular value from the company's products. So yeah, and I think what is very important to understand in this context is the definition of circular economy from Ellen MacArthur. It says a circular economy is based on the principles of designing out waste and pollution, keeping products and materials in use, and regenerating natural systems. So when we speak about recycling and sorting and things like that, that is one part of the circular economy, but there are many other parts as well, such as having good production methods, doing the right thing from the beginning, and also, as you see here, to regenerate natural systems. But if we look at the material circularity indicators, what does it contain? It contains four questions. And the first one is how much of the material in a product comes from virgin sources, recycled resources, or reused resources. And the second question, how much of the product can be recycled or reused? And the third question is how many uses does the product have? And this is very difficult because there exists no standard for how to measure number of uses for a garment. So this is an assessment. Kering Group have made a use phase assessment of their garments or their products, which I think it can be relevant, but not applicable for all. But it will be very generalized data. But you could, for example, measure how long time you expect this garment to be used, or how many times compared to an industry standard for that product type. But since there exist very few standards for how to measure number of potential uses, then this question is very difficult. And then the fourth question is how large part of the products, once they have been used, can be collected for reuse or recycling. And then comes the fifth question that should be in this but isn't. And if you use life cycle assessment or life cycle analysis data or a software, and they usually have this question too, and it is how much of the waste that is generated when manufacturing the product can be reused or recycled. So this is a question that needs to be added to the material circularity indicator. And the flow of the material circularity indicator looks like this. The questions that I just mentioned reflects this flow, but you can just have it for reference. Then the tool looks like this. Quite easy to use. You have these levers here, or these bars that you can pull and see how much of the feedstock is reused, recycled, what's the recycling efficiency, what's the lifespan of this product, and then you have times industry average, destination after use, and so on. So this is a pretty easy tool to use, and gives you an overview. And when you use this tool, you use this you have to do this for every product that you have. And when you've done that, you compile the result from each product in this tool, the material circularity indicator company level aggregator tool. And then when you've done that, you get an overview over how circular your company is. So it can be it could be a fun exercise perhaps to do on some of the products that you have. But I think for starters, I think that this tool perhaps best is used, for example, when you're buying a product or in your product development, that you ask these questions, and then you make your best decision depending on what's available to you. So a little bit about the methodology around the circularity indicators. There are some limitations, and also some what's that? Antaganden. Assumptions and limitations. Yeah. So the indicator doesn't like completely closed loops. For example, the recycled material doesn't have to go back to the original manufacturer in a completely closed loop. The theory anyway explains that should be the case, but the tool doesn't assume that. It's not a limitation, it's an assumption. It is assumed that the reclaimed material can be processed to similar quality as the virgin material, and that is in case of textiles, and perhaps in some cases it's for sure when it comes to reuse of garments, then you will have the similar quality as the original garment, assuming that it's not washed too much. And but if you have washed it a lot, and if let's say that you put the material back into making a new material of it, so you have like cotton fabric and you send that to Renewcell, then it will be a different quality as the original material. So this method assumes that it can be and this assumption sort of doesn't really reflect the dynamics of textile recycling. It is assumed that there is no material waste in preparation of recycling of collected products. This is also not super applicable for textiles, since there is it can be pretty high material waste in some of the recycling processes, especially when it comes to remake. I think then it's like upwards 60% cut waste is not uncommon. Patagonia, for example, whose remake collection was celebrated, had 60% cut waste. It's assumed that the product's mass is not changed between manufacturing and the end of use. So no part of the product is consumed during usage. It's eaten or burned, and this is perhaps true for textiles, that we very seldom eat our garments, even if people sometimes promise that they will eat their hat if something happens. So that was the MCI, and I think, as I said, you're not going to love this tool, but I think you should still have a look at it and be a little bit inspired by the questions that you find there. So the HIG MSI, the HIG index. We will look at the two different tools in the HIG suite. It's the HIG MSI. So that's the HIG Material Sustainability Index. and we will also look at the product module. And the HIG Material Sustainability Index has 5 impact areas. It's global warming potential, nutrition pollution in water, so eutrophication, water scarcity, fossil fuel depletion, and chemistry. And then you can always argue that this is too few impact areas, or that they are the wrong impact areas, but these are the ones that the sort of group behind it has found possible to measure. It is difficult to measure environmental impact because you don't have access to proprietary data. You don't have access to data at all. The data that you get might be skewed. The data in some way, time-wise, or so you cannot trust the data that you get, and so on. And there's a lot of data that you have to collect in your value chain if you want to have a correct, if you want to make your decision based on that data. But this exists anyway, and I think it's pretty good. It's the most comprehensive tool that we have. Yeah. So what it mostly is this, that identify opportunities to reduce impacts and make proactive design choices and design more sustainable products. Let's see if we can skip this one. Yeah. So what it looks like anyway is like this. You have a list of materials, and I think it's 88 materials or so. So we have the HIG material HIG index here. So you have 92 example materials, and each of these example materials includes subcategories of materials. So I would say it's about 1,000 materials in this library right now. So we can have a look at polyester fabric. Like that. And so you see here global warming, eutrophication, water scarcity, resource depletion, fossil fuels, and chemistry. And then you have the individual scores for each impact category here. There used to be an aggregated score, so you can go get the whole, but that was removed for some reason that I don't remember. But then if you want to look a little bit closer, then you can see, okay, here you can decide what is my raw material source, what is my yarn formation method, the textile formation, preparation, coloration, additional coloration and finishing, and what chemistry certifications do I have. And if you want to, you can click here and see, okay, I have Blue Sign certified material, and maybe Ecotech standard, like that. And then your score, then it just says that you have that. Raw material source, and here you can change if you want to. So you can choose different types of polyethylenes here depending on what you have. And if you have Toray, or if you have from Lycra company, or ground to good, you have that in here, and you can look at the different properties here. And I think what is really good here is that we can have a look at this one that we've chosen, and you can see, you can get very detailed information about the fiber, the modeling, how it is modeled in the software, and how when is the data from? Is it quite new data here from 2019? And then you also have some data quality, a good quality, that is new data, that is good geographical representativeness and technological representativeness. So you have quite detailed information around different materials here. And you have textiles, plastics, metals, rubbers, coatings, and leathers, and stuff like that. So this is pretty useful. It's a bit sad, or it's not a bit sad, it's super sad that this is not publicly available anymore. But that's the way they have decided it, and sure, they have good reasons for that. Well, the reason is to make money, so that's why it's now behind closed doors. But I will see if we can get you some access to that. Yeah. Then let's move on to the next tool, the product tool. The product tool uses the MSI data. All my products are gone. Well, that's a bug, not a feature. Okay, yeah. So the product tool works like this anyway. So I want to create a product. And what I do is I write a name, sweater, and then I'm supposed to write the style number, product type, apparel, season, fall, product category, sweater. And yeah, let's see here if we can save and bill of materials. And then I can add a material, trim or packaging. So maybe I just want to add, let's see if I can get the textile here, cotton fabric, for example, add to product, amount, 0.5. That's a heavy sweater. Okay, yeah, 50. Okay, grams. Select that one. And then I prepare my garments. I product assembly, and then I have the cutting and how much is cut. Let's see if I can. Cutting, yeah. And I'm not sure how, but here I specify how much is cut anyway. So I write, Nina, you have to help me here. How long is the cutting?
What do you mean? The cutting?
The cut. How long is that? Can it be for a garment?
You can have. Is it a used fabric? You mean, or
no,
you mean
how long the actual cut is?
The outline. Okay. In centimeters or something. Yes, unit. Oh, I don't know. It was a long time since I worked with this.
Yeah, let's say 250 centimeters. That's not completely off. And then I also can add garment preparation and coloration, garment printing. If I, for example, I have some medium digital print, I add that here and select, and garment washing and finishing. So I build up my maybe I add an let's say an MSI wash for some glossiness of the fiber of the garment. Yes, disposal modes, and here you can see manufacturing waste and excess finished goods material for this product and sample rate for this product. So and now I would like to be able to continue with my garment. Well, anyway, cancel. Review and confirm. It would have been easier if I would just have my sample garments in here. But anyway, at the end of this process, there is this, you get a compilation of your different garments, and I will show you how that looks. It looks like this, the same way as the as in the Higg index or as in the MSI. You have your sweaters here, and you get the different results in the different impact areas, and you can evaluate your products and your assortment in this way. So also quite a useful tool. It requires some effort, but as time moves on, this data, and I think it already is, it will be available for your PLM systems. So it's an open, you can have access through an advanced programming interface to the data to have it in your own PLM system, so that you don't have to work in parallel systems. But when you do your selections in your PLM system, it automatically updates the sustainability data. Some PLM software providers already have that, some don't. I think the one Centrix, the one that bought Teknia-Transcat, I think, I know that they are working on integration anyway, but other software suppliers have similar functionality in their PLM systems. And I think that many of them have some approach to this. So, but then let's say that if you don't want to have a system like this, or you can also create your own tool, like Nudie Jeans have done. They have selected their types of materials that they prefer to work with, and classify them in different sustainability classes. It's easy for people who work at Nudie to have this. You can almost have it lying on the coffee table, so people can have a look at it every day. So it's on top of people's minds, for example. And we have created the similar tools for Lindex that is way more accessible than both the material circularity indicators and the Higg index. And I would say in the end, probably gives similar results. The original tool for this was the Made By environmental benchmark for fibers. Sadly, Made By went bankrupt a few years back, but they had a very simple tool to keep it on top of people's minds. What are the more sustainable fibers, and what are the less sustainable fibers? So I think this, even if this tool is old, and even if the data or the names in there needs to be updated, I think this type of easy, friendly to use tool is very good, and it fulfills the purpose. Okay, so thank you for listening.